So in problem 4.3.4, we have a compound made up of carbon, hydrogen, and chlorine that has a molar mass of 99 grams per mole, and it is 24.3% carbon and 4.1% hydrogen. Now the first step of this problem is if it's only carbon, hydrogen, and chlorine, then that means that the remaining 71.6% must be chlorine. So now that that's taken care of, we can assume percent to grams and assume we have 100 grams of our substance. So if we had 100 grams of our substance, 24.3 grams of it would be carbon, 4.1 grams of it would be hydrogen, and 71.6 grams of it would be chlorine. So we start to determine the molecular formula. We first have to determine the empirical formula, and we do that by converting grams of each element to moles of the element. And when we do that, we find we have 2.025 moles of carbon. We have 4.1 moles of hydrogen, and we have 2.02 moles of chlorine. Now, if you go and you back and you look at your calculator and you look at all of the decimal points I've rounded, the chlorine is smaller than the carbon. Not that it's going to matter a great deal in the long run in this problem. So we take whichever one is the smallest and we divide that into the other two to get the mole-to-mole ratios of the elements to each other to get the empirical formula. So 2.025 moles of carbon over 2.02 moles of chlorine. That's going to come out to be approximately, rounding here, 1 carbon for every 1 chlorine. For hydrogen, we do 4.1 moles divided by 2.02 moles hydrogen and chlorine, and we find approximately 2 hydrogens for every 1 chlorine. So our overall empirical formula, remember we're looking for the molecular formula, the empirical formula is going to be CH2Cl. Now, when I add up the molar mass of the empirical formula, it comes out to be 49.453 grams per mole. When I divide 49.453 into 99 grams per mole, the molar mass of our actual compound, I find that it's twice as much of the empirical. Therefore, the molecular formula has to be twice the empirical formula. So I'm going to multiply all of the subscripts by 2 and find that the molecular formula is going to be C2H4Cl2.